Hey there, and welcome. You know that feeling when you look at a page full of equations and it just looks like a secret code? Well, here's the thing. It is a language, and today we're going to start cracking that code together.
So, is it really a secret language? The answer is kinda. It's definitely a language, but the cool part is, it's not a secret at all. It's more like an open book, and all those weird looking symbols, that's just the alphabet. Once you start to get a feel for them, this whole new world just clicks. So, here's our game plan. First, we're going to really dive into this idea of math as a language. Then, we'll hit the basics, the first few words in arithmetic. After that, we'll see how to make sentences using comparisons, build bigger ideas with sets and logic, and even touch on the poetry of calculus. And we'll wrap up by looking at why knowing this stuff is, well, it's a superpower. Yeah, let's really think about that for a second. A language, it's not just a bunch of problems, right? It's how we describe everything around us. It's how we share ideas really precisely. And that is exactly what math is. Those symbols are just the words it uses. And hey, don't just take my word for it. Galileo hit the nail on the head centuries ago. He realized that the same language could describe a planet orbiting the sun and a ball dropping to the floor. It's the code the universe is written in. How cool is that? Okay, so when you learn any new language, where do you start? The absolute basics, right? The ABCs. And the best part is, you already know the first few words of math. These are the absolute fundamentals that everything else is built on. Let's kick things off with maybe the most famous symbol on the planet, the plus sign. Everybody knows it. It just means and, combine, put them together. It's about as simple and fundamental as it gets. And here's something you'll see a lot in math. Symbols often come in pairs, like opposites. So for plus, you've got minus. Its main gig is subtraction, obviously. But it pulls double duty. It's also the symbol that tells us a number is negative. So one little dash, two huge jobs. All right, next up, multiplication. And this one's a perfect example of how this language has different, well, dialects, you could say. Sometimes you see the little X, the cross. But other times, especially as you get into more advanced stuff, you'll just see a dot. They both mean the exact same thing. You're just scaling a number up. And you guessed it, just like plus has minus, multiplication has its opposite, division. And again, you've got a couple of ways to write it. There's the classic sign with the dots, or the one you see all over the internet and in coding, the /. Either way, it's all about one thing, splitting something up. Okay, so we've got our basic words. Now let's start making some simple sentences. And that's exactly what comparison symbols are for. They're not about a number itself. They're all about describing the relationship between two numbers. And the king of all relationships is the equals sign. Those two little parallel lines. Think about it. 2 plus 2 equals 4 isn't just a math problem. It's a complete sentence. It's making a statement of fact. It's saying the stuff on this side is the exact same as the stuff on that side. And its opposite? Super intuitive. Just a slash right through it means not equal. Simple. Now this is where the language gets really elegant. Check this out. You start with a basic less than symbol. But what if you want to say less than or equal to? Easy. You just add a little line, kind of like half an equal sign. And what if you want to be really emphatic and say something is way smaller, like not even close? You just double it up. See how efficient that is? So much meaning packed into tiny changes. All right, we've got words, we've got sentences. Now it's time for the grammar. This is the stuff that holds it all together. Set theory and logic, these are the rules for how we organize ideas and build arguments that you can actually prove. This is where math starts to get some serious muscle. So, this table breaks down how we talk about groups, or what mathematicians call sets. See the U-shaped symbol? That's union. It's like saying, give me everything from both groups, just don't count the duplicates. Then there's its opposite, the upside down one. That's intersection, and it means give me only the stuff they have in common. And finally, the backslash is for set difference. It basically says, show me what's in the first group, but take out anything that's also in the second group. It's a whole toolkit for comparing collections of things. Okay, now these two symbols are heavy hitters. They're called quantifiers. The upside down A stands for all. It lets you make these huge, sweeping statements, saying that something is true for every single thing in a category, no exceptions. Its partner, the backwards E, means there exists. It's a bit more humble. It just promises that there's at least one example out there that makes the statement true. So, we've done words, sentences, and grammar. You know what's next? The poetry. We're talking about the symbols from calculus and beyond. These don't just stand for numbers anymore. Oh no. They stand for huge, mind-bending ideas like change and limits and, well, infinity. And there it is, probably one of the most famous symbols ever created. It's so simple, so elegant, right? That little sideways 8. But what it represents, it's one of the biggest, most mind-boggling concepts we've ever come up with: infinity. And here's the key thing to wrap your head around. Infinity is not a number. You can't count to it. It's an idea. It's the concept of goes on forever. It represents something with no limit, no end, no boundary. It's bigger than any number you can possibly write down. And check out this one, the integral sign. It looks a little intimidating, I know, but the idea behind it is actually beautiful. It's all about accumulation. It's a way to add up an infinite number of teeny, tiny little pieces to get a perfect, precise total. Like, imagine trying to find the area of a weird, curvy shape. This symbol lets you do that by adding up an infinite number of impossibly thin little slices. It's incredibly powerful. Okay, so we've gone on quite a journey, right? From a simple little plus sign all the way to the concept of infinity. We've cracked a few of the big codes. But so what? Why does any of this matter? Why should you care about learning this language? Well, for starters, it's the only truly universal language on Earth. 2 + 2 = 4 in any country. No translation not needed. Plus, it's the engine running our entire world. Your phone, the internet, AI, all of it is built on this mathematical language. And maybe the most amazing part, it's the language of reality itself. It's how we describe everything from gravity to the weirdness of quantum mechanics. Look, the symbols we've touched on today, they're really just the first few pages of the dictionary. Each one is a tool for thinking, for discovering, for building new things. And when you learn to speak this language, you're not just learning how to solve problems. You're learning how to ask better, deeper, more interesting questions about, well, everything. So what happens next? What can we say with this language now that we're starting to understand it? Honestly, the sky's the limit.